king has been drawn from the deck of cards. So I left with 51. So it's going to be 4 over 51. Yeah? In this case, are they independent? So you know they're not independent. Got it? Got it? Okay, nah? Now my question is this. How do you make these two events independent? You have to do something that make it independent. Very easy. How do you, what can you do to make this an independent? You understand what I mean? You want to make the probability of B equals to probability of B given A. That means I don't care whether A have occurred, the probability of B is still the same. What should you do to this case? You see, that's how I study. I'm not so interested to get through all the notes. I said, oh, that's how it works, right? Now, I want to ask yourself, how do I make A and B to be independent? How? Can you tell me? How? That means I want to make sure these two probability are equal, right? Remember, I told you, right? If they're independent means the probability of A given B equals to probability of A. That means I don't care whether B have occurred, it's equal to probability of A, right? In this case, this looks a bit, okay, if you don't like this, right, so you can flip it the other way, it's still fine. Okay, so let me don't confuse you so much, right? Let me flip this one. Probability of A, right? So probability of A is still 4 over 52, correct or not? Why? Because A, how many kings I have? Also have 4 kings, right? So in this case, the king and queen is the same, right? So I still get 4 over 52. Okay? So now I change this one. Instead of B given A, I change A given B. Okay? I still get 4 over 51. Right? Why? Because after the B have selected, okay, so you can see, I want to find the probability of A given that B have occurred. When B have occurred, what does it mean? A queen is selected, right? A queen is selected, right? So when the queen is selected, how many cards I have left? I have left with 51 cards. Okay? But how many kings are there? I still got 4 kings, right? Because king not selected, right? I still got 4 kings. So it's still 4 out of 51. So in this case, these are not equal to this. Based on definition, they are not independent. Are you following me? Now, my question is how do we make these two events independent? How? Can you tell me the solution? How to make it independent? That means how do I make A given B to be also 4 over 52? If they are the same, then they are independent, right? So how do I make this to be 52? Can anyone tell me? Okay, very simple. Just change one thing only. Just change one thing. Change this thing, say with replacement. When I say with replacement, what do I mean by with replacement? You draw one card. After you draw, you see the card ready, then you put the card back. That's called replacement, right? Then you put the card back, correct or not? So in this case, can you see? The event of B is mean I draw one card which is queen. I say, oh, that's a queen. So what I'll do, I put the queen back to the deck. Okay, because with replacement, right? I put it to the deck. Yeah, when I bring it to the deck, now what's the probability of drawing a king? Also 4, right? But then how many cards do I have in the deck? With 52. Because I will put the queen to have drawn back into the deck. So I got 52. So in this case, I will have 52 here. And because of that, then they are independent. Can you see it? Can you see it? Can I take, very important in the test, when I give you this sort of thing, you need to know how do you calculate probabilities. Yeah? And then you after you calculated the probabilities, then you have to determine whether they are independent or they are exclusive, mutually exclusive. Okay, but my mutually exclusive means you need to see the intersection whether it's equal to 0. If it equals to 0, then they are mutually exclusive. Are you all guys with me? Yeah. Okay. So take note. So if I change this to with replacement, then these two events are independent. If I say without replacement, then these two events are not independent. Okay, they are dependent, right? Because the probability of drawing a king, it depends what card you had drawn earlier. Okay, why? Because the number of cards reduced. Okay, by 1. That means I have higher chance to draw a king. Are you following me? Okay, okay, good. So they know this. Okay, so this is what this means. Okay. Again, these are very trivial example. Tossing a coin and then throwing a dice. Confirm they're independent, right? Because they don't relate to each other. Yeah. driving with a high speed and getting to accident. Obviously, that is dependent, right? Because when drive, the faster you drive, the chances of you getting accident will be higher. Okay, so that one will be more dependent. You got it? Can I? So this is just by looking at things. Okay, so you can decide. But in our case, we don't just based on our gut feeling. We have to calculate, and then based on calculation, the value then you have to determine. Okay. What are you discussing? What are you discussing?
Intern.
Huh?
Internship.
Oh, internship. Discuss after class. Don't discuss now.
Right.
This one is more important.
It's not future problem.
Internship even more future, right?
You know why or not? Because if I listen to this, I go holiday 3 weeks, come back, I forget everything already.
It's not wrong.
So I better you teach us tomorrow one. Better, right? Then
No,
everybody
that means you should do the test today lah. Tomorrow then I can teach, right?
Right. No, you should teach us tomorrow thing today. Then everybody confirm listen one. I guarantee you.
But okay, that's a suggestion earlier, but I can't because the timing. I need to complete the sets of content.
Yeah, you don't say I don't say who know.
Later I don't teach you, you know how to do, then you blame I said I never teach, right? So, no. I'm my own principle. I still want to go through this. So if y'all pay attention,
Guys, I try.
you all pay attention to this. If I have enough time later, I will probably should go through the quiz, the test tomorrow, okay? If you keep disturbing me, I keep stopping here and there, ask you to keep quiet, then no time, then too bad. Okay now, let's cooperate, can?
Yes, sir.
So if you can finish the time before time, anyway, by 3 o'clock I have to finish because another class will come in anyway. Yeah, so if you can finish at 2:30, then I got half an hour to reply to you. Okay?
Yes, sir.
Is that a deal?
No deal.
No deal, huh? Okay, too bad.
Not too bad.
Not too bad, yeah. That's something I hope I want to really complete this so that you will help. I mean, if not, if I go delay this, you will get everything delayed later. Yeah, so.
Okay, sir.
Okay, now, what happened is that now I actually define my S to represent a successful operation. Yeah? So what is what is a probability? Okay, what is over here, right? This is my probability of S. Okay, take note lah. This S is no longer your universal set lah. This is okay. I think okay. Let me don't use S okay. But since the notes use S so let me call it A. Yeah. So probability of A means what? A means the successful operation. Okay. Maybe let me don't use S. Okay. Let me use SO. Okay. SO. Okay. Means successful operation. Okay. So the probability of having a successful operation is 98%. Means that this one is equals to 0.98. Always remember, always reflect always convert a percentage into a decimal. Always, because I told you right, probability always between 0 to 1. Yeah. So don't use 98 in your calculation. You have to convert it into a ratio. Yeah. And then I want to have 3 successful operations, right? And since that's very important, these are independent. Okay. So you can see, I already tell you already. They are independent. I already told you they are independent. That means one operation do not affect another operation. Okay, so successful operation don't affect the other one. Yeah? So I want to calculate what is the probability that I have 3 operations that's successful. That means 3 consecutive operations to be successful. Yeah, so it will be probably S of 0, intersect S of 0, intersect S of 0. Yeah. So then you just need to extend this definition a little bit. Yeah. So can you see? So if they are independent, the intersection is a time. Yeah, so I just need to take probably S of 0 times probably S of 0 times probably S of 0. So it's 0.8 times 0.8 times 0.8. Okay, then you press in your calculator, you'll get this one. Okay, so what does it mean? It means that you have probability of 3 consecutive successful operations will be 94%. Okay, about 94%. Got it? Yeah, so you just need to take 0.8 times 0.98 times 0.98 times 0.98. Yeah, so why you can do a time because they're independent, right? And then you just multiply them, then you get 50. Yeah. And over here, you want to have 2 successful operations and 1 not successful. Okay, so which means what? Which means that you're going to do a you're going to calculate what is the probability of both are successful. So probability of both are successful is going to be 0.98 times 0.98, correct? So both successful is 0.98, 0.98. Yeah? So because they have to occur consecutively. Yeah. And as I said, at least one not successful, right, is a complement of it. Yeah? So that's why I take one minus away. Both are successful, which means that at least one, okay, of that will not be successful. Okay, so the probability is about 4%. Okay, so that means the probability of being not one not successful operation among the three is going to be very low. Okay, very low. Okay, so about 4%. You got it? Okay, so that's how you can actually calculate it. Question? Okay, so remember, you must make sure that this is going to be independent. You can do this because they are independent. Okay, if you are not independent, then you cannot do this. Got it? Yeah?
Yes.
Okay, good. Yeah, so there's a formula. Okay, I leave it to you. This is a conclusion. Okay, so I have already written it right here on the whiteboard here. Okay, so if you have take a understand this diagram and all of the information I've captured here. So it will be here. Okay, now let's finish off with okay, so this one also I've done it. Okay, I'll go skip it. Now I'm going to show you another kind called tree diagram. Okay, so this is a probability tree. Okay, this is something I want you to understand. I have actually two events. Okay, event A. Okay, event A and event B. Okay, so take note. So look at event A. There are two possibilities, right? Whether A occurred or A doesn't occur. Okay, so A occurred or A doesn't occur. Okay, when A occurred, I also know that there's two possibilities, B occurred or B doesn't occur. But similarly, for A don't occur, you also have probably of B occurred and B not occurred. Okay, this one is very important. I want you to know this branch. This is very important. Okay, what this branch means? This branch means that I want to calculate the probability of B given that A have already occurred. Can you see or not? Because if I go through this path, right, to calculate this probability, this must have already occurred, right? If this don't occur, then it don't make sense to follow this path. Yeah. So this path itself means that the probability of B, you want to find the probability of B given that A have occurred. You got it? Yeah. So similarly, this one probability of B prime given that A have occurred. Okay, why A occurred? Because we trace back this event must occur already. Yeah. So that's where the A have occurred. Understand? Yeah, so similarly for the other two ones. Okay? So if you're going to take a look at A, okay. If you're going to take a look at probability of B, okay, so this is just a formula. Okay, so I don't talk so much about this, but this is important.
Yeah, she was lah, but she okay.
Okay, this is important. So what does this mean? Okay, again you look at the formula, very complicated, right? I teach you how to do this. So if I draw a probability tree, you want to find a probability of B. You ask yourself where the probability of B comes by. Okay, you come by here. This is one path, and this another path. Correct?
Correct.
Yeah.
Yeah.
And these two paths they are independent. I mean they either you follow that path or this path, right? They cannot both, right?
Yes.
So that's why you need to add them.
Yeah.
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 And then when you follow this path, which is number one here. How do you find the probability of B? Basically, you take probability of A times the probability of B given A, which is this one. Can you see that? That is 1. Okay? And this is, let me call this as 3. Yeah? So, there's another B occurring there, right? So, how do you find the probability of B there? Is to take probability of A prime multiplied by probability of B given A prime, which is this one. So that. Okay, so in this case, once you understand using the probability tree, so once you understand how to construct this probability tree, you basically do not need to remember this formula. Because this formula, that's how I show you, right? From the tree itself, you can actually derive the formula. You don't need to go and memorize the formula. Okay, so that's something I like about mathematics, right? So you don't need to remember this. Okay, I don't even write this here. You see that? So once you got a probability tree already, you ask yourself what you want to find. Then you just traverse your tree to get the respective probability. In this case, case 1 and 3, they cannot happen at the same time. Okay, they are disjoint. Okay, being disjoint, that's why I need to add them. You got it? Okay, so you'll see this again in your tutorial and also in your test subsequently. Yeah? So that's how you do it. Okay, good. Now we are saying all this. Now I think it's a good time to show you how do you draw. Okay, see the notes already. I already draw the tree for you already. Okay, but in actual test, right? You only see this. You only see this one. You only see the question. Okay, you need to draw the tree yourself. Yeah. So over here you can see you have 15% of adult smoking. So straight away smoking is one attribute. So I go to have smoking and not smoking. Okay, since the smokers is 15%, non-smokers will 85%. Okay, because this S prime, right? So it's S plus S prime must equal to 1, which is this formula, correct? No? Okay, so that is why if this point 15%, this is going to be 85%. Huh? Okay, so then he also found that 62% of the smoker. Okay, take note. Given that I'm a smoker. Okay, I smoke, then 62% I will get a lung problem. Okay, so can you see? Lung and not lung. Yeah, so if I'm a smoker, what's the probability of me developing a lung problem will be 62%. So that's why it is up. And then this one, you just take 1 minus 62 is 38%. Okay, so if I'm not a smoker, then I have 12% chance to develop the lung problem. Yeah, so if I'm not a smoker, I get 12% chance to develop a lung problem. Yeah, so if I don't have a lung problem, that will be 88%. So far, okay? So that's how I use that formula, that first paragraph to draw my tree. So, right? So this tree is not given to you. This tree you have to draw yourself. Okay, so in the notes, I actually given to you. Now, what I want to do, find the probability of a randomly 60 years old adults have a lung problem. For example, right? I want to find this probability, right? When the lung problem actually develop, two different cases, right? Here and here, correct? So you just need to take 0.15 times 0.62, add on to 0.85 times 0.12. Okay, and then you calculate, and then you get 20%. Okay, so there is a 20% chance that if I'm 20% chance when I randomly select a person, right? He has a lung problem. Okay, so it's about 20% chance. So follow me? Okay, nah? So then I want to say that given a randomly selected 60-year-old have lung problem, what is the probability that he smoke? What does this mean? That means I want to find the probability of smoke as given that he have already had lung cancer, he had a lung problem. You follow me? So can you see? Now read this question carefully. Yeah. So this is given. Okay, because I already know, right? I already know that this adult already have a lung problem already. Okay, then I want to find what's the probability he smoke. So that means this is basically referring to probability of S given L. Are you with me? Okay, so that means given that he really have a lung problem, but I want to find what's the probability that he smoke. Okay, definitely it's very high, right? So I mean, if you do calculation, you know it's really high. Yeah. So how high is high? So that's why you do the calculation. What you need to do is to calculate what's the probability. Over here, you just open up using the formula. Okay, so it's the probability of P S intersect L. Okay, so basically it is a smoker. It's a smoker, and it actually developed a lung problem, right? So it's 0.15 times 0.62. Okay, then what's divided by probability L? Probability L you already found just now above, right? So you just substitute the value inside. Then press the calculator, you get answer. So it's close to 50% chance. Yeah. If he have a lung problem, if the 60 years old adults that you pick up have a lung given that he haven't had a lung problem, what is the chance that he smoke? Very high, about 50% chance that he's a smoker. Are you following? Got it? Yeah, so that is how you can use your probability tree to solve all these probability problems. Yeah, so basically one of the things is you can use a tree to determine this, okay, and then use that tree to help you to solve all the probability questions. Okay? Yeah, okay, good. Let's move on. Okay, so again, this one is a bit repetitive, except that now we got three machines, right? So ABC got three machines, whether 40 or not 40, yeah. So what's machine A make 20% of the components, so 20% is made by machine A. Then 30%, this given here. So I have A, 20%, I have B, 30%, then the C have to be 50%, right? The rest have to be 50%. Okay, that's how with that I form this tree. Yeah? So 0.2, 0.3, 0.5, 20, 30, 50%. Yeah. Then what's the probability for A? Okay, for the machine A, 0.06. Oh, sorry. 0.07 is 40 when it's made by A. Okay, so we made by A. This one is made by B, and this one is made by C. Okay, can you see all my symbols? Okay, so then from there I just will fill up 0.7, 0.07, 0.06, 0.05. Yeah, and again, what is the other probability? The other probability will be going to be 1 minus that, right? So this is going to be 0.93. This one is going to be 0.94, and this one is going to be 0.95. So far, following? Yeah, very easy, right? So just make sure all these branches that add together, okay, coming from a single point must be equal to 1. Okay, so these add together equal to 1, add together equal to 1. All these add together must also equal to 1. Yeah, so that's why it is. Yeah. Now, what is the probability of component made by machine A and that is 40? For example, right, is A and it's 40, right? So you just take 0.2 times 0.07. Are you following? Okay, so quite straightforward. Then the next question is, what is the probability of the component is made by B given that it's 40? Okay, so this is a bit tricky. Yeah? So is this is probability of B given that it's really 40. Okay, so you can see this one very similar to just now that question, right? So if you open a formula, this is going to be probability of B intersect F divide the probability of F, correct or not? But this one, probability of B intersect F, very simple, right? It's probability of B intersect F, that means you take 0.3 times 0.06. Got that? But then the difficult part is below. What is the probability of F? Then now can you see you have three different things. 1, 2, 3. Got it? So the below one, right? How to find the probability of F, right? Is going to be 0.2 times 0.07 plus 0.3 times 0.006 plus 0.5 times 0.05. Got it? Because this is probability of F. So you have to multiply all these all the way down to all the way down from it. You understand what I'm talking about? So this is very similar to just now the question, except that now this one you have to go and find your F yourself. Okay, so last question, they actually ask you to find the probability, this probability first, right? Then the second part they make it obvious. Yeah? So in this case, you have to find it at this point. Got it? Yeah. So if you go and take a look at the solution, right? That's what it is. So can you see below? It's a long thing to go, right? Why is it such a long thing? Because you got three F here, right? 1, 2, 3. Okay, so that's why you need to take 0.2 times 0.07, which is the first one, 0.3 times 0.06, which is the second one, and 0.5 times 0.05, which is the third one. Alright, and then you press your calculator, the answer will be 31% or 32%. Are you all following me? Clear? So, basically, once you understand the notation, once you understand how to write all these intersection union or given, yeah, then you can just make use of formulas that's given to you, just expand it up, the next question is that how do you calculate them? Okay, you can calculate them using of the method I showed you just over here, and then substitute the value inside, and then press on calculator, and then you're done. Question? Easy, right? Very easy?
Yes, sir.
Okay, thank you. Good. Alright, last one, last question. In fact, second last example, okay? So, now I'm going to show you, okay, just now I show you using a tree, right? Now I show you using a table. This one I already show you this. So when you see a table, right? Very mechanical, don't need to think so much, okay? Very mechanically go and find this.
Some of it actually don't look like.
Remember no? Remember that's what I told you, right? And what is this? This is your grand total. Okay, this is your grand total. Okay, and then these are your row total. These are your columns total. Got it? Yeah. So then what you do is that they ask you to find what's the probability of type A, right? So very simple. Look at the column of type A. Where is type A? Type is here. Look at this column. Look at this number. Divide by the grand total. Then that's answer already. Easy or not? So it's 164 divided by 409. Okay, so that is the question part 1. Part 2, also very simple. Positive, right? What is the positive? Positive is here, right? You look through. How many I have? 334. Grand total 409. You take 334 divided by 409. You understand what I'm talking about? Easy, oh? So over here you just take a grand total of type A, which is 164. Then you divide by 409. Okay, this one you take 33344 divided by 409. Alright, so this is your column total, this is your row total. Okay, then divide by your grand total. Okay, next, what is the probability? Okay, what is the probability of A? Okay, let's call this O, A, and B. So let me call this whole thing by here as an event. Okay, let me call it RP and Rn here. Okay, so I want to have R probability of A and is RP. Okay, I want it to have the resonance positive. Okay, at the same time it's a blood group A. Yeah. So how you do this? Very simple, right? This one you just take the probability that in fact the first two, right? Okay, in fact this one is probability of A, right? This one is probability of RP, right? Alright now, because positive resonance factor, right? So resonance factor positive, right? So this is RP, that is P of A. How do you find the intersection? Very simple, use a formula. Okay? Use this formula. Okay, you want the intersection? Basically, you shift this over, you bring that over, then you get probability of A plus probability of RP minus away the union of both of them. You get it? Oh, sorry, no need. So sorry, no need. If you want the intersection, right? This one, sorry, no need. You want the intersection, basically you actually look at this number. Looking at A and RP, right? So you are looking at this number. Okay, so you don't even need the formula, okay? Because that number 139, right? Basically is a number that it's an intersection, right? A and RP, correct now? That's the number. Okay, so the answer is 139 over 409. Are you with me? So you don't even need the formula. Okay, so because when you do the intersection means what? You are actually looking at the numbers. This column intersect with the row. This number is the intersection, right? So this A intersect RP. So straight away I know that it's 139 divided by, so grand total is 409. So far so good? Can I? The next one then you need the formula. So the next one what I want to find? I want to find probability of O union R of N. Correct or not? That means I want to find the type O, or is negative resonance factor, okay, which is probability of O union probability of Rn. Okay? So this one no choice. This one you use the formula. So this one you use the formula. Probability of O plus probability of Rn minus away probability of O intersect Rn. Got it? So what is probability of O? Simple, right? Look through the O column, straight away you get the number 185, 184. What is Rn? Look at Rn, look through the row, 65, so you plus 65. Okay? What is O and Rn? Okay, so it's 28. Okay, so you minus away 28, take the whole thing, divide by 0.09. So that's answer. Are you up with me?
Yeah.
Okay, so you need to know how to look at the table, where is the value and so on. Alright, so after that you just do press on calculator, you get the answer. Okay? And the last one. What is the probability of RP given that is AB? Correct now? Can you see? I want to find the probability of the positive resistance factor given that it is a type B, type AB block. Yeah? So in this case, you just use the formula, okay? So equals to probability of RP intersect AB divided by the probability of AB. Okay? And as I said, you can use this formula, you can do it, yeah? For me, you know what I'll do or not? Once I get the table, right, I actually had shared with you last week. So where I know it's given AB, right? So I look at where's my AB. My AB is here. Okay? Now what did I do? Okay, you don't believe me? You go use this formula, you should get the same answer as me. Yeah? So this is what I'll do. Since I know this has already occurred, right? Can you see given AB, right? I know this already occurred. So what is my grand total now of after knowing AB? My grand total is 16. Okay, no longer 409 already, yeah? It's 16. Why 16? Because I know the AB group has to occur first, correct or not? If this occurred, what is the probability of having that being positive? Answer is 12 over 16. Okay, so can you see straight away I get the answer as 12 over 16. If you don't believe me, you use this formula, at the end of the day you still get the same answer, 12 over 16. You understand how to use my table? Yeah, so once it's a conditional probability, very simple. You're going to shift your grand total either to your left or to the top. Okay, because I also can ask you this, right? Find the probability of a block group O given that it is negative. Okay, so then in that case, what has happened? Rn has happened, right? So now my grand total is 65 already. Okay, so what's the probability of O? O is 28, so this one is going to be 28 divided by 65. Okay, so I know this is not in the question, but I just want to let you know. If I have this conditional probability I want you to find, so can you see my grand total has shifted from 409 to 65. Okay, why shifted to 65? Because of the negative. Yeah? The whole row of negative 65. The probability of O, where's the O? O is here, right? 28, right? So you say 28 divided by 65. So that's the answer. Got it? Okay, so I show you how to use a table to calculate the probability. I show you how to use a tree to calculate probability. Yeah. And then the last question or the last example, okay, you can look through. So this answer. So I let you look through them. Okay, the last one we are going to use a formula to calculate it. Yeah. So this one is another good example. Take note, I given A and B are mutually exclusive. Means what? Probability of A intersect B equal to 0. Okay? Okay, I already written here already. Okay. Then the independent means the intersection is equal to the multiplication, yeah? Because A and C are independent, right? So probability of A intersect C equal to probability A times probability of C. Yeah? The rest, what you do is very simple. Just use the formula and then substitute the value and then you're done. Okay, I'll show you what I mean. I want to find probability A union B. Then I use this formula, right? A union B, I use the formula. Okay, so I put the formula up. And since I know A and B are independent, right? So the intersection is 0. So I just need to add probability of A plus probability of B. So the answer is 2 over 10. You got it? Yeah, what you know why this is 0, right? This is 0 because they are. Can you see the intersection here is 0? Okay, because they are mutually exclusive. Okay? So, the next one, what is the probability of C? Okay, let me see. Okay, this is part 1. This is A. Okay, this is B. Yeah. You want to find the probability of C? Okay, I'm going to use this formula, right? I know what is the probability A union C. Okay, probability A union C is given here. Okay, so this one is given here, which is 7/15. Okay, and what is probability A intersect C? Because I know A and C are independent. This one is just a product. Okay, it's probability of A times probability of C. Okay, I know the probability of A, which is 1/5. I know I do not know probability of C. I need to find, right? So I just put in 1/5 here, 7/15, and this is 1/5. Yeah. So then what I do, I just solve for P of C. Okay, that answer is 1/3. Are you with? So this one doing nothing. Okay, I just use the formula. I just substitute the probability values into each of the items, and then I simplify it, and then I can answer. Are you okay? So this is just using formulas. And the last one, you want to find probability of B intersect C, right? So same thing. You want to find the probability intersect C, you just use probability of A union. Use this formula. Then just plug in all the formulas, and then you arrange them, and then you get the answer. Yeah, because this I think B union C is given, right? Here. No, this B union C. Yeah, so this is given to you. Probability of B is given to you. Probability of C that you have found earlier 1/3. Okay, so this one you found is 1/3. Okay, so you just need to substitute the things like is it 23/60, 1/10, 1/3. This one you want to find. Then shift them around, you get answer 1/5. Got it? Okay.
Just with a rough one.
Okay. So any question? Okay, then they ask you whether this B and C are independent or not. Very simple, right? So you just need to, you already calculated the intersection 1/20, right? You take the probability of B, 1/3, 1/10, the probability of C is 1/3, is 1/30, right? So they are not equal. Okay? So that means they are not independent. Okay, so B and C are not independent. Okay? Any question?
Everybody need a report.
Okay, if not, okay, good. Maybe it's a good time for a short break, okay? Give you 15 minutes, okay? Come back. 8 P8, which is equal to 8 factorial. Okay, so that's the answer. Is it? Why? Because of OR, right? This OR is telling me my R is also equal to 8. Remember, for permutation, we talk about NER. Okay, so in this case, my R is also 8. Why 8? Because it's all the letters. Yeah, so the R is 8. Yeah. Over here, what is this for? This for is my R. Okay, so this is going to be 8P. Oops. This one is going to be 8P4. Okay, so this one is going to be 8P4, which is going to 8 factorial divided by 4 factorial. Okay, so that's the answer. Is that easy? Very easy, right? Okay, good. Next, this is also very easy. What is this? This is my N, correct? This is my N. How? Yes, this is topic 6, correct. But tutorial 3, yeah? Yeah. So this N is N equal to 6. Okay, why 6? Because I got 6 digits. Okay? And then this, what is this 3? This 3 is my R. Okay, so then I want to have no, okay, remember all the P and the C, all the P and C have always have no repetition. Okay, so this first one, very easy. It is going to be 6P3. Got it? I can use, always remember, Remember the diagram I showed you last week? Yeah, so once you have no repetition, then you can use permutation and combination. When are you using permutation and combination? Permutation is where the order is important. Combination. Hey Louis, come on, go back to your friend. No, to your friend. Huh? Go, your friend. Right, so permutation is always important, combination always not important. Yeah, take note now. Both cases, no repetition. If you see repetition, you cannot use P and the C. Remember? Huh? So in this case, if I want repetition, what will the answer? The answer is going to be 6 to the power of 3. You all know how to get 6 power of 3 or not? Why? Because I got 3 different locations, right? Alright now. And how many ways can I fill up these first digits? I got 6 ways. Okay, so if I got 6 ways, right? If I say with repetitions a lot means what? I pick a number, I can take the number and throw it back to the pool. Yeah, I can reuse it again. Yeah. So the next one, how many numbers can I use? I can use another 6. I can use another 6. Okay? And since for the pin number, right, all the 3 digits must happen at the same time, right? So I need to multiply together. I need to take 6 times 6 times 6. So that's why it's 6 power of 3. Are you following me? This one is the same. If you want to draw a diagram to solve this one also can. You have 3 slots. This one is going to be 6, 5, and 4. Can you see the difference between the first question and the second question? Can you see the difference? The first question is that once you pick up the number, you are not going to put the number back. Okay, because you don't want that number to repeat. Okay, so you will draw out, you go hold it, you're not going to put it back. Okay, so that's why when you draw one number, you got 5 numbers left. You draw the second number, you got 4 more numbers left. So that's why it's 6, 5, and 4, and this is equals to this, which is equals to 6 factorial divided by 3 factorial. Follow me? So either how you represent it, just make sure your concept is correct. So that's how you do question number 2. Yeah. Question number 3, also very easy. The only thing you can see is what? With non-distinct, right? Because you can see papaya, right? P appear 2 times, A appear 3 times, but Y is unique, alright? So how many ways can I? In this case, take a look. I want to, how many ways can I do it? I got 2P, 3A, and 1Y. Okay? So, how many ways can I arrange this? Is 6 factorial way. Okay, you all know why 6, right? Because it's 2 plus 3 plus 1. Okay, 6. But then I got 2P repeating, 3A repeating, I need to divide by 2 factorial, 3 factorial. Okay now.
Before I come to school, I must finish first. Okay, sorry, I shut up.
Yeah, sit down. Don't listen to the class. I know you are very good in it. Don't do
I stupid.
Alright, so. Okay. For permutations, you can see the T is only T is repeating, right? The rest are not repeating, right? There is no repetition except the T, right? Agreed? So then you have to, okay, so in this case, I'm going to count how many letters here, right? So I already counted for you, I don't to spend the time counting. Totally, you should have 12 characters. Then you divide by 2 factorial, okay? Why 2 factorial? Because got 2 T's. Are you following? So why 12? You got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters, yeah? 12 letters. 2 T is repeating, the rest are unique. So that's why you just divide the repeating word, right? So that's why. Okay, so, okay.
I will end the entire game.
You want the end answer or not? I can give you an end answer if you want, but this is a very big number. 2, 3, 9, 500, 800. Very big number. Okay? And this one equals to 60. Okay, and this one equals to 120. And this one equals to 216. Okay, so in case you want the number, this one equals to 40320. And this one equals to 1660. Okay, so all these are the end answer. Okay, so You just take your calculator and press your calculator and verify for yourself. Right? So that's the answer I give it to you. Okay? Can I? Okay.
Amen.
Next one, combination. Okay. First part is very easy. I tell you a permutation combination. So this one definitely you have to use C, right? So now in this case, I have this astronaut need to have some dietary. Yeah? So he need to eat one veggie. Okay, he need to eat one veggie, 2 desserts, okay, and 1 main. Okay, so he need to have these few things. That's he need to have 1 main dish, 1 vegetable, and 2 desserts. Alright? Then you ask yourself, how many? Let's see. How many desserts? How many ways can you choose? If there is 10 main, 8 veggie, and 13 desserts. Okay, so this one quite straightforward, right? So it's going to be 10, choose 1. Why 10 choose 1? This is for the main course, right? I got 10 main, and you choose 1. Yeah? Vegetable, how many vegetable I have? I have 8. How many I need to choose? I also need to choose 1. So this one is going to be 8 choose 1. Dessert, how many dessert I have? I got 13 of them. Okay, I got 13 of them. I need to choose 2. Okay? And I need to form this whole thing as a meal, right? So that means all this must happen at the same time. That means I have 1 meal, 1 veggie, and 2 desserts. Okay, all these will come together. So that's why you need to multiply all of them together. Okay, so that's why you need to do a multiplication. Okay, so then if you work out the solution, the answer is 6240. Okay, so you just go and press your calculator. Okay, so this one is 10, right? This 10, this 8. This one is 13 times 6, so probably about 90 plus. Okay, you multiply them together, it's 6240. Okay, so that's our answer. Sorry, easy, right? Okay, next. Over here, take note. This is my n, right? This is my n. This is my r. Okay, this one have to be very careful. This total number of people, that's n, make up of two different group of people. Yeah, you have boys and girls. Okay, 13 girls, 7 boys. Okay, and out of that 20 people, I need to get 8 of them to form the committee members. Yeah. When I know restriction means what? I don't care about whether boy or girl, right? So in this case, I be getting 20 choose 8. Got it? Why? Because there are 20 people there, right? When I say no restriction, means I don't care whether boy or girl. Yeah. So as long as I form 8 of them into the team, I'm fine. Yeah. So in this case, it will be 20 choose 8. Got it? So why? I told you already, right? What is n? N is 20. What is r? Is 8 because of this, right? So if you use the formula and calculate the answer, I give an n answer. You go and check it yourself. It's 125 970. Okay, so this is the total number of ways that you can do it. Okay, and then you want a committee that make up all girls. Okay, that means 5 of them are girls, right? So how many girls can I choose from? I got 13 of them, right? So I go take 13, choose 8. Right? So because I want all to be girls, right? So I want all the 8 to be girls. But now my n is no longer 20, yeah? Now I want to look at girls, right? Now how many girls I have? I got 13 of them, yeah? So I got 13, but I need to choose 8 of them. Yeah? So this is the number of ways I have. And that answer is 1287. Are you all following me so far? Quite easy, right? So once you understand the concept, it's pretty easy. Now you have exactly 1 boy. Okay, so if you want to have 1 boy, means what? How many girls you have? You might have 7 girls, right? 7 girls, 1 boy, right? Because you only have 1 boy, then the rest of the 7 must be a girl. So that means this have to be 13 choose 7 times 7 choose 1. Got it? So that is how I can form the girl. This I can form the boy. Yeah. So boy, how many boys I have? I have 7 boys, right? I said you choose 1 of them. Okay. So in this case, when I look at the solution is going to be 1 2 1 2 0 1 2. Yeah, correct. Hopefully I got it correct. Yeah, correct. Okay. Now, the last one quite easy. You want the less than 2 boys, right? So the only case you have less than 2 boys is either you have 0 boy or 1 boy, correct or not? So you can see this one is equals to 1287 plus 12012. You know what I mean? So I already calculated, right? No boys, part 2, right? That means no boys means all girls, then only have 1 boy here. So if I want to accommodate less than 2 boys, that means it's only have 2 possible cases. One case is all girls, another case is only 1 boy with 7 girls. Yeah, so in these 2 cases, why you see why I need to add them together? Because either you do this or this, right? You cannot do both, right? So I add them together, then you get the answer. And 13, 299.
Yeah. Everybody.
Got it? Can I? So you can see when I do it very simple. So this one is not easy. Okay, this one is not easy. How many of you have tried this? Okay, this question number 6 is not easy. Okay, now you will see in one box you have 3 green balls, 5 red, 7 yellow, 6 blue. Okay, I have 4 different colors. Yeah, with all the different numbers there. Then what I want to do is this. I want to go and pick up 2 balls. I want to pick up 2 balls such that the 2 balls must be of different color. They must not be of the same color. So I'll do this. Okay, so you understand what I mean? So this is your, if you want to look at this is whole thing is your N, right? And this is your R, correct or not? Correct? But take care, you cannot just add up all the N. You cannot add 3 plus 5 plus 7 plus 6, add them together and then choose 2. You cannot. Why can't you do that? Because if you do that, then there will be a possibility that 2 balls are the same color. You understand what I'm talking about? So I cannot take 8 plus 7 is 15, 15 plus 6 is 23, right? I cannot take 23 choose 2. I cannot. If I take 23 choose 2, then I will have possibly 2 balls that have 2 green or 2 red or 2 yellow or 2 blue, which I don't want. You see, I want to make sure that these 2 balls I pick must be different colors. You got it? Okay, now? So how do I do it? Very simple. Just need to think a bit. Just think a bit. Let's assume I go to pick up the first ball at red color. Okay. If you don't believe me, you don't care what color you choose first. Just determine the first color that you want to choose. Okay. I let you go back home and verify for yourself. Okay. Then someone asked me, why must I pick red? Can I pick? Oh, sorry. I don't pick red first. Okay. Let me pick green. Okay. Okay, there is no magic. There's no magic. Why I pick the green first? Okay, because it comes as sequence. Green, red, yellow, blue, right? You want to pick the yellow first, also can. Doesn't matter. Okay, but of course the solution that you give me will be slightly different, but the total end answer is still the same. You understand what I'm talking about? Okay, so I let you go back home and prove to yourself. So the first one, I want to pick a green ball. If I go to pick a green ball, how many green balls can I pick? I can pick 3, right? Right? So that is 3. That is 3 green ball. Okay, so that means the first one has to be a green ball. The other one is not green. Correct now? So in this case, how many green balls I have? I got 3 of them.
Won't get wasted.
How many not green balls? Then I'll have to add them, right? 5 plus 7, 12, plus 6, 12 plus 6, 18. So it's 18. Are you okay? Okay, so that is the number of ways that I actually determine the first one is a green ball. Follow me? Okay, now since I already picked the green ball already, right? I should not pick the green ball anymore, right? So I take away the green ball. So when I take away the green ball, what I had 3 more colors, right? Red, yellow, and blue, right? So I consider red. Yeah, again, same thing. Why I consider red? Why can't I consider yellow or blue? No problem. You can consider blue, yellow, or blue. Doesn't matter. But the answer in between, of course, the answer is slightly different. When add everything up, you should get the same answer. Are you with me? Can So if this is going to be a red ball, okay? If this is going to be a red ball, and this is not red, minus way green, take note, I cannot have a green ball here. You know why? If I have green ball here, then this will repeat. You understand or not? Because the first one I have a green ball and followed by all the other color ball, right? And all the other color balls I have 5 possibility of having red there, right? Got it? So in this case, I cannot have the green ball here. I only can have first one to be red. The next one has to be any other color except green. Why not green? Because green ball I already counted here already. You got it? If not, then you double count. Okay, so how many red balls I had? I had 5 red balls, right? I have 5, right? I got 5 red balls in there, right? So how many not red minus the way green? So not red minus the way green, I'll have 7 plus 6, right? So I get 13. 13.
That's why you spec me first, eh? That's why you spec me.
Follow me?
At the start of the lesson.
And then the last one
哎，我今天没有立标。
is going to be yellow. Okay? Anyway, the last one I will do 2 options.
这要你把来个。
Okay? If it's yellow, then it's 7. Then this one has to be blue, right? If this is yellow, this one has to be blue. Correct? Or the other way, you flip the other way, right? If let's say you choose a blue ball first, right? If I choose a blue ball here, the next one has to be yellow, right? So you just split the thing. So instead of 7 times 6, you get 6 times 7. But you still get the same answer. You know what I'm talking about? Can So then, and all this, and all this must, all these are actually don't happen all together, right? So it's either this or this or this, correct? Okay, so then what you do, you just calculate what is this. This one you multiply them, you get 54.
No, he got MA.
This one you get 65. This one you get 42. Then you add all this together, answer is 161. So there's totally 161 way for you to pick up 2 balls that different color.
Obsessive.
Ready? So if you don't believe me, you go and do the same thing and do exactly the same thing. You start, depending what you like, what color you like. Okay, for example, you like the blue first. Okay, you start with blue first.
I don't obsessive something.
Okay, then you do the same treatment. You start the blue first. Then in this, let me start you off first, okay? Then I'm not going to complete it. You're going to complete yourself. Huh? So you start with blue ball. How many blue balls I can choose? 6. Okay, how many not blue ball? It's going to be 8 plus 7, so 15, right? So you have 15 here. Are you following me? So next, once you select the blue ball, you have to take away the blue ball. So you have the green, red, and yellow. Then again you choose. Then of course you can see in between answer may not be the same, right? But if you add everything together, you still get the answer as 161. Go back and try. Yeah. So why I choose all these colored ball is because it comes in that sequence, so easier for me. Correct? So if I choose any number, it's still fine. Okay. At the end of the day, you still get this number as 161. Any question?
No.
Clear?
Today was a wonderful lesson. 这样马上找 lesson， 对不啦？马上找。
Yeah, yeah. Yes.
来，全部站起来。乖。
Okay. Okay, good question.
Okay.
How do you punch in your calculator 13C7?
Why also bullying me?
Okay, Louis, come. How do you evaluate this number? 13C7. How?
Number 30, then row 7.
Knock your head.
That's siao
No. I want to get a number. What is this number?
What you mean by you want to get a number?
What is 13 to 7? Okay, you can either use your calculator.
13 exclamation mark over 7 exclamation mark.
Close. That close. Very good. Close. Okay.
Close up, fuck
Calculate correctly, not fully correct. 13. Okay, what is 13 exclamation
you.
mark
13
mean?
minus 7 exclamation mark, you see.
Yeah. Okay, so 13 exclamation mark is 13 times 12 times all the way times 1. Yeah. In your calculator, you should say exclamation mark by right. If not, then the manually time them together. Then this one will be 6 factorial, 7 factorial. Okay, because the formula is this. NCR equals to n factorial divided by n minus r factorial, r factorial. That's the formula you should use. Okay, that's how you can press in your calculator. Got it? Good question, in the test number 2, Don't just give me 13C7, then I ask you give me the actual value, you don't know how to press the calculator, then you lose your mark. Okay, so that's how you do it. That's use of formula. Got it so far? Okay, good. Okay, this one I really want to, for part B, I leave it until when the sun starts 10, yeah, because if I go on, I think I will not able to finish it. So let me stop here. Okay, maybe let me spend I have about 15 minutes, right? Let me spend the 15 minutes to talk to you about your tomorrow test. Okay?